Hey folks, since we have performed something known as advanced featureization, along with that we have performed couple of data analysis including some of the advanced analysis often known as t-SNE. Again, t-SNE in a nutshell, it is often known as multivariate analysis. This is what we have done till now. Again, apart from advanced featureization, we have also done something known as some basic featureization, some basic data analysis and some basic statistics on top of the data that we have. Now, in this entire module, our main challenge is all about, let's try to find the vectors of the data that we have. Again, the core idea behind just to find the vectors of the data is, imagine I have some question, let's say question 1, and let's say I have some question 2. Imagine I have two questions, let's say this is my Q1 and let's say this is Q2. And what I need to do is, I need to just pass both the question 1 and question 2 to my machine learning algorithm. I will say, hey, this is my both the question 1 and question 2. Hey model, can you tell whether Q1 and Q2 are similar or not? So it means I need output in the form of zeros and 1. This is what I need. But here comes a funny thing. The moment I pass Q1 and Q2 to my machine learning model, as Q1 and Q2 typically belongs to text data, and we all knows that machine learning, basically in a nutshell, machine learning is all about nothing but mathematics. It is all about some mathematics equation. It's all about linear algebra. In a nutshell, it's all about vector. It's all about calculus. That's the core idea behind the machine learning that we have. So it means what we need to do is we need to convert this text into something known as vector, because vector is nothing but a number. In short, vector is nothing but a number that has some direction. Similarly, I have to also convert this into some vector. It means I basically need a vector representation of the text that we have, so that my machine learning algorithm will able to understand what exactly my question is all about. Because machine learning only works with mathematics, and we know mathematics works only with numbers. Hence, we need to convert this text into something known as vector. That's a core idea why there is a need of natural language processing algorithm. In a nutshell, this will just convert some text into vectors. That's a layman explanation of our natural language processing algorithms. Doesn't matter whether it is BAO, doesn't matter whether it is TF-IDF, doesn't matter whether it is word2vec. Again, there are tons of algorithms just to do this, but these are some of the most often used algorithms in context of even real world. Again, there are some instances where you have to use some cutting edge of algorithms, but these are some of the most frequent used algorithms. So first and foremost, let's try to rename the notebook that we have. So I will say, let's say 7 ... let's say NLP, which is all about natural language processing algorithm. Cool. Now first and foremost, let's try to import all the necessary stuff. So I will say import pandas as PD, and let me execute this line of code. Using PD, I have to call an inbuilt function, which is all about read_CSV. Because first and foremost, we need to read the data that we have. You will figure out this is the path. This is the entire path where my data is available. So I have to just copy this path and I have to just paste over here, because that's what my signature says. That's what my signature says. First and foremost, I have to mention some file path where exactly my data is available. So I will say, let's say this is a file path. Cool. Once I will mention the path, then I have to mention what exactly is my dataset name, which is all about nothing but NLP_features_train.csv. And let's try to append R, which is all about raw string. That helps Python just to read file very efficiently. Let me cross check the file name that we have. It is cool. Now it just returns some data from object. Let me store that in, let's say in data. Let me execute this line of code. Cool. And if I will say data.shape, now you will figure out over here you have 10,000 data points or 10k data points. And the moment I say data.head of, let's say 3. Cool. Let me execute. Now these are typically two questions that you have, on which you have to apply something known as natural language processing algorithm. So the first and foremost problem statement is all about, algorithm is all about something known as TF-IDF. Again, for those of you who do not know what exactly TF-IDF is all about, kindly check out my previous video where I have explained all the necessary stuff regarding TF-IDF. Again, the core idea is, let me explain all the existing algorithms, or let me explain the 3 algorithms that we will use over here just to convert some text into something known as vector. Let's try to explain me from a layman point of view. Again, in a nutshell, first algorithm is all about binary of words, which is often known as bow. So imagine I have some text, let's say T1. So it just returns a vector representation in the form of either 0 or 1. This is what in a nutshell binary of words does. On the other hand, TF-IDF says, hey, TF-IDF says, I will return, again, just to maintain the semantic relationship of some text T1, it returns the value in the form of floating nature. Let's say 0.1, 0.7, let's say 0.6, and blah, blah, blah. This is a text representation of T1. Now here comes an interesting algorithm, which is all about word2vec. Word2vec, in a nutshell, word2vec is all about. So the moment I say I have some word, so just to return its vector representation, it's all about our word2vec algorithm. In a nutshell, that's what word2vec does. So again, the key advantage of this word2vec is it maintains the semantic relationship up to greater extent. Again, there are some instances where TF-IDF fails. There comes your word2vec algorithm. Again, at some of the instances, just to improve the existing word2vec, you can think of something known as, which is all about a mixture of TF-IDF plus word2vec, which is nothing but TF-IDF weighted word2vec. This is all about one of the extremely popular algorithm just to get the vector representation of some document that we have. That is one of the extremely used algorithm in context of real world. So the first and foremost assignment is all about, let's try to apply the TF-IDF on data. So first and foremost, I will say, hey, let's try to cross check again. This is the unnecessary column name. First and foremost, let's try to drop it. So I will say it's all about nothing but data.drop, and cool. I have to mention this feature name, which is all about this. Let me remove this, and just to update it, you can think of a very handy parameter, which is all about in place parameter. So I can just press tab, and this is exactly that parameter. Cool. I will say true. Cool. Let me execute. And what I will do is, again, you have to pass something known as x equals to 1 because you have to drop in a vertical way. Cool. Let me execute. And if I will say data dot, let's say head of, let's say 2. Let me execute. Now you do not have any such column. Now let's try to implement something known as TF-IDF on top of our data that we have. It means we have to implement TF-IDF on question 1, along with, we can also think of applying on top of question 2. Again, let's try to apply this TF-IDF in this session, and as we gradually progress, we will touch upon some of the advanced algorithms. So I will say from this scikit-learn module, I have something very fancy which is all about feature underscore extraction. Let's just press tab over there. So this is exactly that sub module. From this, I have to go inside something known as text. From this, I have to import, again, just to import the binary of words or bow, you can think of importing something known as count vectorizer. If you have to implement something known as TF-IDF, you can think of importing something known as TF-IDF vectorizer. Cool. Let me just execute this line of code. Now, first and foremost, you need to initialize your TF-IDF vectorizer. So I can say lowercase equals to false because I do not need to consider my lowercase. I can say lowercase equals to false. Cool. Then I can say, let's say its object is all about, let's say TF-IDF. Cool. Now using this TF-IDF, I will say, hey, can I call the something known as fit underscore transform on top of our question 1 feature, which is all about nothing but this one. And whatever, again, the moment I call fit underscore transform on top of this question 1, it just return a matrix representation or the vector representation of the question 1 feature. So just to store that, I can think of storing this in matrix. Let me execute this line of code. And if I will say, hey, can I print you? So this is exactly the sparse matrix. In a nutshell, sparse matrix is all about where I have very few non-zero values. And this is typically the size. Now this matrix says there are total 10k data points. It means there are total 10k observations. And just to represent those 10k observations, you need probably close to 11.7k feature names just to represent these 10k observations. That's what its dimension says. And it belongs to numpy.464. It means the element the element inside this 10k cross 11.7k, which is all about our dimension of TF-ID vectors. Over here, the element that we have, they belongs to a float data type. Now, just to visualize this metric, what I can say is I can say, hey, can I call something known as toArray on top of this? The moment I will execute this line of code. Now you will see this is the array representation of the data that we have. Now what we need to do is, let's say I will say of 0. Now you will see this is the array, or this is the vector representation that you have. Now if I will say data of question 1 of some index, let's say 0. So what is the step-by-step guide to invest in India in share market? The vector representation of the entire text is this one, because the array is all about nothing but a vector representation of all the data. And the moment I pass the index 0, which typically points to this text data that we have, it means this is a TF-ID vector representation of the below text that we have. So in the upcoming session, what we will do is we will try to find a TF-ID scores of entire data. Along with that, we will also try to find a TF-ID scores of some random question as well. That is typically our main goal in the upcoming session. So that's all about it. Thank you. Have a nice day. Keep learning, keep growing. Again, for those of you who have any doubts, feel free to ask with us in the Q&A of the course. That's all about it. Thank you. Have a nice day. Keep learning, keep growing, keep practicing.